people can't fly. This is not realistic. But I kept on dreaming.
This year, OCX is excited to host an inspirational keynote speaker internationally known. We are excited to welcome Cedric Dumont, high-performance psychology expert, book author, and Red Bull athlete. Cedric is a pioneer in wingsuit, flying, and base jumping. He's pushing the limits of what the world thought impossible. After over 13,000 jumps worldwide, Cedric learned that collaboration and trust are make or break in high-pressure environments. And having everyone working towards a common goal is essential for success. Cedric has shared this message around the world for the past 17 years, and this year he will be joining us at the Open Community Experience in Mainz. It is now time for the open source community to take the leap into ultimate collaboration. Are you ready to get inspired at the Open Community Experience 2024?
Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Kito Man, who will be presenting on the topic of Expect the Unexpected. If you have any questions for Kito as we move through today's presentation, feel free to ask them in the chat or the Ask a Questions tab. Without any further delay, Kito, over to you.
Exceptional conditions in enterprise Java applications. So just a few words about me. There we go. All right, so my name is Kito. I'm the principal consultant at Virtua, where we do training consulting, development, mentoring, architecture, etc., along the axes of Java microservices, Jakarta EE, web components, Angular, and also cloud as well. We also work with migrations from older versions of Java, older versions of Jakarta EE, and all that fun stuff. We're also working on a side project called speakertracks.com, which is a service built for people who do a lot of frequent speaking and developer advocates. And we're also the official US partner of PrimeTech, which is an open source UI component vendor. They have components for Prime Faces, for Java server faces, or Jakarta faces, I should say, and also libraries for Angular, Vue, and React. I wrote a book a long time ago. And also I'm the co-host of the Stacked podcast. And if you like podcasts, I encourage you to check it out. Stacked is every month or so a podcast that comes out, and me and a few other co-hosts, Daniel Inahosa, Ian Lavitz, and Josh Juno. Three of us are Java champions, and we all talk about latest technology trends, a lot of stuff in the Java world, front-end development, and we usually have a guest on from the community. So if you like podcasts, I encourage you to check that out. I'm a member of the Jakarta EE Ambassadors Leadership Council. That's where we just work to make sure people are aware of the features and the potential of Jakarta EE. And I'm also been involved with the Java community process for a long time. I used to be a Google developer, expert in web technologies, et cetera, et cetera. All right, so that's me. There's only a few of you on the call right now, but I would love to hear from those of you who are here, sort of what your background is, like how long you've been building applications. Is it like, 5 years or less, or is it like 10 years or more, et cetera, et cetera. So So if someone could put that in the chat, I appreciate it. But give me just a handle of who I'm talking to. Okay, we got a 5 years or less. All right, got one response there. All right. So I'm going to say that gives me at least a vague idea of the audience, which is good. All right. So basically, what I'm going to be talking about are different things that you should think about when you're building applications in terms of things that might go wrong. Okay. So if you think about it, bad things can happen, right? And it can be something simple like, oh, there's a horrible rainstorm. It's bad, but it's not that big of a deal. You can get stuck in traffic. This is in India. You see, there's a lot of traffic there. It's kind of going to take a long time to get where you need to go, right? So you can imagine if you're building an application and this happens, you might want to come up with a way to handle it other than just sitting there in traffic forever. What you often hear from developers is they say that should never happen. And, you can say that should never happen, but, they do happen. Like there's tornado, it actually happens. Tsunamis, they happen. And some bad things seem minor, right? So, here's a rusty pipe, right? It's not a big deal, but maybe it is, because what's going to happen is whatever's going through there is going to leak, right? So whatever we're expecting to get from one end to the other we're not going to get as much of it as we expect. And then there may be surrounding impacts for whatever is leaking out of there may actually have an effect on the areas around it, right? So it's really not as straightforward as it seems. Potholes seem like a minor thing, right? Until you drive over one and it messes up your car or causes an accident or hurts somebody who's sitting in the seat or something. So what exactly is an exception? An exception, the word's a noun, and it just means something that is accepted, an instance or a case not conforming to the general rule. So as developers, we generally like to think that things are going to go okay, and the code that we write initially is the happy path, right? But I'd like to encourage everyone to think about, the non-happy path, the sad path, the bad path, right? So what happens when things don't go your way, and how is your code going to react? So I want to encourage you all. Whoops, wrong button there. Excuse me. Let me fix that. The beauty of live presentations. And we will go back over here. Sorry about that. Just totally lost my window. There we go. All right. Okay. So I want to encourage you to expect bad things to happen, because in the real world, things do happen, right? We all know when we're working with some application on our phone or a website, things just often don't go right. And a lot of times we encounter this behavior. We encounter an application that doesn't work the way we expect it to. So what you want to do is ensure that, or try to ensure at least, that regardless of what is actually happening, your application behaves consistently. So I'd like to talk about a few of what I call exception handling aphorisms. So these are some things to just keep in mind as you build applications, trying to ensure that they are resilient. So the first thing is, do not eat exceptions. And whenever you write code and you're doing a try catch or some other statement where you're handling an exception, try and remember this. This is probably the most important thing. And remember this guy, remember this face. don't eat exceptions. So what do I mean by that? Well, it's very simple. Here we have a simple Java method. This could be any code, any application framework, but it's UI code, right? So we're processing something, we're saving a widget, okay? So we're saving the selected widget. And if there's a database exception, we catch it, and then we print out the stack trace. And then we display to the user, your widget has been created successfully. And what's the problem with this? Well, the problem is that it hasn't been created successfully. It failed, but we're telling the user that it actually was created successfully. So essentially what's happening here is we're actually lying to the user. And the application is now in an inconsistent state, right? It's like it sort of thinks that the save was successful, but it wasn't. So like, for example, if this was being displayed in a data table or something, that widget wouldn't actually show up. So the application would say, hey, the user, the widget was created successfully, and then it actually wasn't. It won't show up in the table, and the person will be sitting there going, wondering what happened. And I think we've all been there before. You add an entry to an application, and it doesn't happen. And a good example of this is my wife and I use an app to track meal entries, like different things that our daughter is eating for different meals, because she has type 1 diabetes, and we track her health and her meals and everything. So there was a bug for a while where we would add an entry for a meal, and it would it would act as if it was successful, and then it just wouldn't ever show up. And it turns out there was a bug somewhere in their back end. If the items that were added to the meal had certain attributes, like they were custom foods or things like that, it just wouldn't get saved. But that's a good example, because they weren't handling the exception properly. They were acting as if things were going okay. So this is probably the number one thing you want to do, is make sure that users actually know when something's wrong. All right, so here's another one. Does anyone see anything wrong with this code? If anyone wants to put it in the chat, you can let me know. Other than the fact that we're eating exceptions, right? Which we don't want to do. But what actually happens, and what's the drawback of this? This is admittedly a very contrived example. But if anyone can think of what the drawback of code like this is, can you put it in the chat? Okay, so I don't have any answers, so I'll help you guys along here. So what we're doing first is we're saving the widget, right? So we're saving it, and that's fine. But obviously, what's happening here is if it fails, we're just eating the exception, we're printing out the stack trace, and then we're shipping it, right? So we're performing another operation, and this operation depends on this one. So basically what's happening here is if this one fails, we're then still shipping it, but it hasn't been saved. This may cause an issue downstream, because the implication is, or the expectation is, that when something is saved, we also will ship it. But we shouldn't be shipping something if it's not saved. So this is an area where we really shouldn't be continuing if this first call fails here. Okay. The other thing is that if that scenario happens, if either one of these calls fail, the caller, whatever code is calling us, doesn't know, right? It has no indication that there's a problem. So it's going to go on about its way, thinking everything went away. It might send a message to the user saying, hey, your widget was processed successfully, but that didn't actually happen. So this is a good example of just why you shouldn't catch an exception and eat it, okay? So what do you do if you aren't supposed to catch it, right? Well, the basic rule is if you can recover from it, you catch it, log it, and tell the user if necessary, okay? Pretty straightforward. So in this example, just going back to the first example I showed you, we get the widget provider, we add the user, add the widget, excuse me, we say it's been created successfully, etc. So if this line here fails, it's going to jump to here, right? It's going to be caught. And then we're going to display the error. Hey, sorry, it wasn't a database error occurred, right? We're not going to clear off the selected widget because the widget's still selected and it hasn't been added, right? So in this example, we actually have the correct behavior. We're catching it, we're logging it, and then we're still, the application is still in a consistent state. If the user tries to save it again, they're going to get the same error if the same error occurs. But we also have it in the logs saying that there's an error accessing database, and then we have the actual exception there. So in this example, we're properly catching and logging the exception. If you can't recover from it, don't catch it. And this is something I think a lot of developers struggle with at first, is that they think if there's an exception being thrown, especially if it's a checked exception in Java, they think they're supposed to catch it, but you don't have to. So in this example, we could do something like this as well, where we don't actually catch the exception. And what's going to happen in this case? It's going to really depend on your application framework and what is set up, right? So in some situations, what will happen, what should happen in this situation is there should be like an error page displayed or something, right? So what's happening is you're not catching the exception because you don't really know what to do with it. And whatever code there is that's calling your code should eventually have something to handle it. So that exception handler may display an error page saying, hey, there's a system error or whatever. Now, clearly, in this situation, if it's a user interface, that may not be the best thing. Maybe the other option we had before was a better way to handle it. But that depends on your system, whether or not it's better to let everything bubble up or to log it and catch it. And that's the key thing is, can you recover from it, right? So maybe in this scenario, you couldn't actually recover because the fact that the widget couldn't be created is a major issue that you want to, stop the user and tell them about. So who knows? But that's something to keep in mind. Okay, so that's the basic deal with eating exceptions, right? We don't want to eat them, and we want to throw them when necessary. But we also want to throw meaningful exceptions. And what do we mean by that? Well, there's in Java and in most languages, there's different exception types, right? So in this example here, we are showing, we're sending a message, right? And obviously there would be some other code down here, but if the message length is less than 5, we're going to throw in a legal argument exception. And that actually makes sense because it's legal argument, but we probably could be a little more logical about it. We could say a little bit more about what's going on here, right? So here, we actually are saying it's a legal argument exception, and we're explaining exactly what the problem is. Message must have more than 4 characters, right? So it's just simple validation. Obviously, this is a very contrived example. But here, the exception actually means a little bit more, right? And we're definitely not throwing just a runtime exception or a raw runtime exception or a raw exception. So here's another example. So often you'll see people do something like this, right? They'll, in this message method, we call get message. And if it's within the service window, we retrieve the message. Otherwise, we throw an exception, and we throw a runtime exception because we don't want it to be checked, right? And we say service is not available now because it's outside the service window. So this will work, right? It gets the point across. But the problem here is that the only information we have is, the only details we have is the text that's here, right? So in the logs, we'll see something like this, exception in thread main, and we'll see Java Lang runtime exception, service is not available now outside service window. Okay. And that works, that gets the point across. But we actually could take this a step further because Java has types. And one of the things we should do when we're writing code is actually use the type system to our advantage. Because if I'm searching for information about exceptions, I could search for this string, outside service window. But what if I actually had an exception type, right? So what if I just had an outside service window exception? I could find all the instances of outside service window exception in the logs, right? And this gives me a little bit more information. And I don't even have to give it a message necessarily, because this actually conveys all the information that was in that text message before. It's outside the service window. Now, maybe I could provide more information about, where in the service window, like, that it's 4 o'clock now, and the service window was between, 1 and 2. Okay. That could be the case. But the idea here is that we're using the type system to provide more information about the errors that occur. So not only can you have a base exception or an exception that makes sense, like outside service window exception, but you can also have a hierarchy, right? And so in this sort of very simple example, we have an exception. We have a runtime exception. I generally prefer runtime or unchecked exceptions in Java. And here we have a persistence exception, which is the base exception. And then we have like an entity exists exception, entity not found, database not available exception. All these are, sort of basic common ideas. You'll find analogous exceptions like this in most persistence frameworks. And you'll find that if you look at the Java exception hierarchy, there are different exceptions, right? And they mean different things. And that's how you actually build code where the errors make sense to the developers and the systems that consume the output from your code. Also, what this allows you to do is you can add additional functionality. So maybe there's something about a persistence exception that every persistence exception has that you want to be able to provide to anyone catching that exception. And a typical example in like a microservice framework might be like the MDC, which tells you sort of essentially it lets you correlate different requests to the same user, the same transaction essentially. So you can provide different metadata in your persistence, in your exception hierarchy that can help out with this. So another thing you want to do is if something does go wrong, you want to strive for consistency. So in this example, we're working with a JPA session, and we're basically just saying, if it's we're basically just grabbing the object, right? And if it's stale, we're evicting it, then we're deleting it, and we're flushing it, right? And the reason you need to think about this is because whenever you work with any resource like this, you want to make sure it's closed when you're done, right? So in Java, you can use the try with resources block, which is what we're doing here, which basically ensures that no matter what happens, we are actually closing this particular session. And if you're using an old version of Java, you could use the try finally, but it's the same idea. So basically, whenever you're working with resources, you want to make sure that you try and use the try finally block so that they're closed appropriately. Okay, so we said if something goes wrong, we want to strive for consistency. And the key thing to remember is that eating exceptions generally causes inconsistency. That's just what it does. So we wanted to strive for consistency before in the previous examples, but this doesn't, right? This makes your system in an inconsistent state, which we don't want. All right, so another aphorism is that system out println is not a logging framework. So if you're putting system out.println in production code or the equivalent in a different language, you don't want to do that. Also, e.print_stack_trace doesn't use a logging framework. Okay, so in the examples I've shown where you're eating exceptions, obviously e.print_stack_trace is not really a good production solution. Okay, it's useful for debugging. It's very handy for debugging prototypes, initial stabs at code, but your production code should not be using system out println or e.print_stack_trace in most cases. What you should be using is a logging framework, and Java has lots of logging frameworks. One other thing I want to mention is that if you're, well, let's just take a step back. So one of the key benefits of a logging framework is that you have control over the output location. So if you do system out println or print stack trace, it goes directly to standard output, right? And usually that's easy to capture, and you should be capturing it anyways, right? And outputting it some file somewhere, right? But a logging framework lets you control where the file is stored. Okay, it lets you segregate error messages that are printed to error log or other types of messages. It lets you do some segmentation if you want to. You can control, whether the logging level, whether you want to do tracing, error, debug, info, etc. And you can change those values depending on the environment. So, if you're in production, you probably don't want to do trace, right? But when you're testing or debugging, you want to turn on tracing and give yourself more information. So logging frameworks are essential. And even if you have a logging framework, it doesn't mean that everybody's using it all the time, right? So I've seen a lot of legacy code or a lot of code just that other people wrote, right? And they may be using a logging framework, but I still find a lot of instances of e.print_stack_trace, a lot of instances of system out println, because people are not using it consistently, and that's the key thing, is consistently, right? So one of the things to keep in mind is that, let's say you're working on an existing code base, and there is a logging framework in use, you can just go ahead and change these. If it's system out println, you can change it to the actual logging framework. If you see an e.print_stack_trace, you can change it to use the logging framework. So those are just some things to keep in mind, is that you can sort of incrementally make these changes. Another thing to keep in mind is that you could do this on the front end too. So a lot of people think, oh, a lot of this logging stuff, a lot of these things are really just back-end concerns. They're not. All these concerns are viable for the front end as well, because there's a lot of code there as well. So on the front end, it's helpful to use a logging framework as well. It's a little bit easier on the front end because console, the browser API is pretty useful. Like, it already has like different logging levels and stuff, so you can get away without it a little bit more. But the logging frameworks give you more flexibility, so I encourage you to do that on the front end as well. Another thing you want to do is ensure that your logging output is consistent. This is the big thing, especially when you're building lots of different applications across an organization or across the system, different microservices, different micro front ends, etc. And what you want to do is try to ensure that your output is formatted in a consistent way. So that thing means things like date, time, thread, method, other metadata that the logging framework is outputting, and where it's being located, okay, or where the files are being placed, or where it's being consumed by a system that does log analysis. And the main reason you want to do this is you want to ensure that anything that's consuming your logs actually can do it in a consistent way. And the main, I'd say probably a good example of this is, if you are ingesting your logs into a system like Splunk or CloudWatch and AWS, or the equivalent on some other logging or some other cloud platform, if you have to write queries against the logs for one application, and the logging statements look completely different than queries than the log files for another application, what happens is you're actually going to cause more work for whoever is the person who's parsing those log files. And I've done that before. I've been the person writing queries in Splunk, and the log files are very inconsistent. And we needed to be able to provide a lot of analysis and dashboards based on the logs. And the more consistent the logs were, the better the dashboards were. So it's important to try and make sure these things are consistent, especially if you have several different microservices or you have an ecosystem where things are working together. And this is a big one for me. So you don't want to log an exception more than once. And unfortunately, this is a pretty common problem I've seen. So let's look at a little demo. Okay, so here's an example of a little bit of Java code. Very simple here. We've got the service, and we're wrapping it in this other service. And then we're calling my repetitive service a send message. Okay. So send message is a very simple method. And what it does is it sends a message repeatedly. It does it a few different times. And if it gets an exception, it catches it and it eats it. And then, actually, it doesn't eat it. I'm sorry. It catches it, it logs it using print stack trace, and then it throws an exception, right? And this is a very common pattern I've seen, where we catch it because we feel the need to log it, and then we throw it. And what can happen in this case is we end up with something that looks sort of like this. Okay. So we get the stack trace, and there's an error. Let's say there's an error in production or a test environment, and we want to look into it. And we look at it and we say, okay, there's a legal argument exception. Okay. Oh, and there's a legal argument exception. And okay, so the error is that the message must have 4 characters. Okay. But we send, and we see this, and we see this, and we see it multiple times. And this is the exact same error, right? But why are we seeing it so many times? It only happened, presumably, once. Maybe it happened more than that. I don't know. It's kind of hard to tell. And this happens because when this code was written, the assumption was that anytime there was an exception, it needed to be logged. So in send repeatedly, there's another try catch. And again, we're iterating through this. Okay. And if there's an error, we do print stack trace. So not only is this frustrating when you're looking at the actual logs to figure out, okay, what actually, where is the root cause? I see this exception, 10 times. But also, if you're doing any sort of log analysis, you can't tell how many times the error occurred. Like you can't, if I were to do a query against the logs and say, okay, on this day, this exception was thrown 10 times, it would be wrong, right? We don't know how many times it was thrown. So what should happen is we shouldn't be logging it, right? And so if I run this code here, all of a sudden we get the exception 1 time, right? So this is the root cause, the legal argument exception, okay? This is where it was thrown at the top level from this main method here, right? Okay. So here we only see the exception basically 1 time. We see the exception is thrown at the top level, and we see the root cause, right? And this is what we want. So just by avoiding logging the exception when we don't need to, we actually get things handled properly. And what's happening here at the top level is it's showing up in standard output, right? If you're using some sort of framework, we could ensure that it is handled at a top level in one place, okay? So this is a very important thing that I see all the time, is a lot of people that feel the need to log all the time, which you don't need to do. Okay. Anyone have any questions so far? Okay. All right, no questions in the chat, so I'll move on. Okay, so I've mentioned a few times that you can use tools to analyze logs, and a lot of companies that, or organizations, companies that have moved to a cloud provider, they already do this. They use CloudWatch or something like that provided by their cloud provider. There's actually a lot of different options. So Splunk is one that I mentioned before. Datadog is another one. AWS has CloudWatch. Azure has Monitor Logs. Google has Cloud Logging. There's also the Elk stack if you want to take an open source approach. There's other competitors, logz.io, Graylog, etc. But the benefit that these tools provide is the ability to ingest lots of logs from multiple applications and then let you do queries across them and create dashboards to analyze them. So this lets you do things like say, okay, well, if something happens in this service, can I correlate what's happening between multiple different services? That's where you get into distributed tracing. But basically, it also lets you just do simple queries and complicated queries against the logs for a single service. So you can find out, how many times this error occurred, or other analysis about different events that you may want to keep track of. So I encourage you to take a look at those tools as you build your applications. Another thing you want to do is capture client-side errors, and this is actually a relatively new thing. Let me take a step back. I would say that the maturity of the options in this space have gotten much more mature in the last few years. This is something that I've been doing for a while, but there are now lots of tools to help you do this. So, and basically what we're talking about here is the ability to essentially capture any errors that occur on the client side and then save them somewhere and then do the same sort of analysis you would expect on server-side logs. Logging frameworks like Sentry and Rollbar can capture error details in real time, and which is very handy. And then you can also, at the very least, just send your errors to a microservice, and then in that microservice, just save it to some log location and then ingest it. That's the simplest solution. So basically, what we're saying here is that when something happens on the client and the browser, we want to ensure that it's stored somewhere and then we can analyze it to determine what's happened. Because otherwise, what happens is, you get server-side logs for whatever goes on there, right? But when something happens on the client, nobody knows what's going on. And then it takes a long time to figure out exactly what error is occurring on the client as well. Also, if it's an important error, you want to notify immediately. And this is tricky because sometimes you have applications that have a lot of false errors that are being reported, and that usually occurs when there's unnecessary logging, right? So if you're handling your exceptions properly, there should be no false notifications for important errors. And you can do this by using a logging framework. And the logging frameworks have different appenders. So that instead of just appending to a text file, they can append to an email or SMS notification. Also, log analytics tools are an easy way to do it. So if you're using Splunk or Datadog or AWS CloudWatch or whatever, you can configure them to send out alerts when they see certain errors. So just important to keep track of that, because I've worked with a lot of clients where they're getting all these exceptions in the log files, but nobody's looking at them. There's no actionable work on it. People only look at them when there's like a production issue that someone's complained about. So it's better to be proactive about these things. Another thing which I like to do is define an error response contract. So when you're building an API, if your API has an error that it wants to communicate to the API client, it's helpful to give that error a standard format. And of course, you want to use the proper HTTP response codes for REST responses. That's all pretty normal behavior, right? But if you have some information you want to convey that's over and above 500 server error, you can, instead of just displaying arbitrary JSON, you can just have a specific contract. So you say, okay, this is my error message. This is a special error code that I have for this. These are particular details about what's happening. That way the client can make an informed decision about how to handle that error. Okay. And one of the things I've noticed, I've built REST endpoints, but also GraphQL endpoints. And GraphQL is an alternative to REST. Same sort of thing, but provides some different features. And it allows you to, let me take a step back. All the error messages in GraphQL are always in a standard format. So the way these messages look is something like this. So this is the query, this is not the error. So this is a query, right? And this is saying, okay, this is, I'm going to get the profile. And this is actually an example from the Speaker Tracks application. So I'm going to get a profile, and I want the speaker profile for ID J. Now, J is actually not valid because the ID is a number, right? So we should expect an error message back. GraphQL displays it like this. It says errors, and then it says what the message is, where the location was in the query, and then gives you details about the error. Okay. All right, so it should be it should be an int value or string value, but it was an enum value. And there's some other information here. So there's a standard format that says this is the error message, right? But also you can provide extensions if you want to provide more information to the client. So this way the client knows that not only, was this the message, but this was of type validation error. Okay. So the client can say, okay, well, there's a validation error, this is what the problem was. And then of course there's no data being sent back. So this is the way GraphQL does it by default, but if you're building REST endpoints, you can just come up with your own standard JSON format that your clients understand. And that way, whenever there's an error, there's a standard way to explain what went wrong. Okay. So another key thing you want to do is centralize exception handling. So I've said before that in cases where you don't know how to handle the exception, you want to just let it bubble up, right? You don't want to handle it. If you don't want to handle it, if you don't know how to handle it, and your code cannot recover, you want to then let that bubble up to the top. And at the top level of whatever application or framework you're working with, you need to handle the exceptions there. That's where we have a centralized exception handler. And it can handle all sorts of things. It can handle logging, so it can do that final output of logging to some log location. It can do notifications, so maybe you wanted to notify you via SMS or some other notification system, calling some sort of notification API, PagerDuty or something. It can display an error page if it's displaying a UI. It can display in standard error format, right, like we talked about. So you can do all these things inside your custom centralized exception handler, and that can be fine-tuned to your organization's needs. So on the back end, you can do this with Spring with the global error controller, which gives you a centralized place to do this. And pure Spring MVC, there's this, you can implement a controller advice with an exception handler. Gives you similar functionality. And Jakarta RESTful Web Services, which is part of Jakarta EE, you can use an exception mapper class to do this. It doesn't redirect to an error page. You have to write a little bit of code for that, but it's not very difficult to do. So you can do that as well. Micronaut has a generic exception handler class, gives you the same sort of functionality. And I should mention this applies to MicroProfile as well, since it uses Jakarta RESTful Web Services. On the front end, if you're using React has this handy thing called an error boundary that you can put around your root component. And you can actually have multiple error boundaries within your component tree in React. So you could very easily have an error boundary for your entire root component that does some logging and does some additional work, maybe displays a standard error message, etc. Angular has a custom error handler you can write, same sort of thing. It's not based at the component tree level, but it does give you a central way to handle errors. Vue has the same thing with an error handler, and pretty much any other front-end framework is going to have something similar. So you also want to try and standardize your error handling strategies. So within the same application, all your errors should be handled in the same way. So obviously, if you're using a logging framework, you should use it consistently throughout. And you want to try and handle or not handle the exceptions, as I mentioned before, in a consistent manner. Another thing you can do is actually document the standards, right? So if you come up with a standard way you want to handle exceptions, you can just document it. You can say, okay, for applications that are use this framework, this is how we handle exceptions. Simple and straightforward. Another thing you can do is across different applications, try and use the same libraries for logging, error handling, that sort of stuff, so that developers that work on different applications can do it consistently. Also, you want to try and implement the same standards even if we have different languages. So, if you have some code that's written in Java, some is written in Python, some is written in TypeScript, whatever, try and come up with some common standards about how things are done. And this can be done. This can be more at the level of common logging formats, right? So, if every log or line of logging, I should say, has certain things like thread or date stamped, whatever, just make sure they're all in the same format. The dates are all in the same format. That the different attributes that are saved are in the same format where they can be, and that they're all ingested in the proper way or stored in standard locations, things like that. So a few other things that I want to mention. If you have a service and you're calling other services, you want to make sure you handle failures as well. And this can be done in microprofile, Spring Boot, or with third-party Java libraries like Failsafe and other microservice frameworks. And they give you some of these common patterns for working with downstream calls. So you can retry a certain amount of times to another service. You can have a circuit breaker, which basically does a lot of retries and then waits and then tries again. You can have just basic timeouts so that you're not waiting forever for your call to fail or respond. You can also have a bulkhead, which is basically saying, let me run all the requests for this downstream service in a separate thread, a separate thread pool, so it doesn't affect the rest of the application if it takes a long time to respond. You also can fallback, which is basically saying, okay, if this downstream service doesn't actually respond, or doesn't respond in a certain amount of time, etc., I want to fall back and do this other thing instead. That's a good way to handle error messages, right? You could say, okay, well, none of this stuff works. I at least want to fall back on something that logs it and then tells the user something, right? Also, you can have a rate limiter, and what that does is it lets you, if you have some sort of API service where there's like a limit to the amount of calls that people can make, you can handle things that way as well. So also, you don't want to forget about observability. So, I've been focusing mostly on exception handling, but when it comes to the whole world of handling errors, you want to have a lot of monitoring, metrics, distributed tracing, all these sorts of things, because these let you get a better handle on how the system is performing, especially if you have different microservices, how they're interacting with each other, et cetera, et cetera. So to summarize, you want to expect bad things. Bad things will happen. You don't want to eat exceptions. If you can recover from it, catch it, log it, and tell the user if necessary. If you can't recover from it, don't catch it. And this is a key thing. If you can't recover from it, don't catch it. What this ensures is that something at the top level, usually a global error handler, will catch it for you. Okay. You want to throw meaningful exceptions. And by that, I mean usually a specific type that explains what the exception is. This again makes it much easier to find different instances of the same exception and makes your code very meaningful, and also uses the Java type system or whatever language you're using. If something goes wrong, you want to strive for consistency. So you want to make sure that your application behaves in a consistent manner even when things are going wrong. You want to use a logging framework consistently. So even if you have a logging framework in place, you don't want to have system out.println and e.print stack trace all over the place. You want to ensure that your logging output is consistent, meaning that it's in the standard format, so that it's easy for different logging ingesters to ingest and process. And you don't want to log an exception more than once. So don't do e.print stack trace, or even just use a logging framework just because you caught an exception. Only use it when you can actually recover from the exception. Keep in mind these different tools I mentioned to analyze logs. You want to capture client-side errors as well and make sure that they can be analyzed just as well as the server-side logs. You want to notify immediately for important errors. So if there's a major issue, you should actually have someone that is notified accordingly. And you want to make sure you centralize that exception handling, because if you don't catch the exception when it occurs, something needs to handle it somewhere. And by having centralized exception handling, you can ensure that it's handled in a consistent manner, regardless of where it's occurring in your application. Okay, so I want to leave you with one thing here, which is don't be that guy, right? You do not want to be the guy that writes the code that eats all the exceptions. So, all right, so with that, I will leave it open for questions.
Amazing. Thank you so much, Kito, for that excellent presentation. So yes, as we wrap things up, please everyone put your questions in the Ask a Questions tab or in the chat. We do have some very exciting news to share, and that is OCX, Eclipse Foundation's flagship event, previously known as EclipseCon, is coming up next in Mainz, Germany on October 22nd to 24th. EclipseCon will be a part of OCX, so that material and information will still be shared. But we do have a co-located event for our open community for Java. And registration is open, and I have a little video from our program manager, Tanya, who you all may know for Jakarta EE. So I'm going to play that here quickly for you all and hope that everybody has an opportunity to register and attend this amazing event.
It's much more ambitious, it's broader, it has a dedicated space for the Java community, and even more so for enterprise Java community, which are a lot of projects reside at the Eclipse Foundation related to enterprise Java, but we're inviting other Java projects as well. So yes, while we're focusing on some of the projects from the Eclipse Foundation, we're broadening it up and inviting the whole Java community to participate and take advantage of the open source and project that are residing at the Eclipse Foundation. Open community for Java is designed in such a way that it is actually appropriate for everyone interested in Java. So while we're focusing on developers, we're absolutely interested in decision makers who will be able to figure out all the projects that we're doing at the Eclipse Foundation and how that relates to the broader Java community, and embrace it in their teams, with their employees and in their companies. It's super exciting news.
Yeah, thank you very much. All right, so I'm going back into the Ask a Questions to see if there's anything in Keto. It doesn't look like I have any questions in the chat or in the Ask a Questions tab. So thank you again so very much. We love having you join and share your knowledge with the community. And we hope that everybody have an amazing rest of your day, wherever you are.